Just zoom right out. If you zoom right out,
hit that bottom button.
Okay. Okay. So. Okay. So today, I'm going to dedicate this lesson to our folio task. All right, for a number of reasons. I think firstly because we've had a couple of people away on work experience, just give them an opportunity to catch up with us. Secondly, because we don't want to get too far in front of the other class. And thirdly, because once we've started, then when you have extra time in other places, you can dedicate some to the folio. So we're not wasting time. The sooner we start it, the more of it you can get done. So today's going to be an opportunity for me to read through, and I'm going to give. Will, could you get the door there for? Thank you. I'm going to give part one a pretty solid address, and from there I'll mention part two briefly, and you'll have the capacity to start it. But I won't go into too much detail about how we're going to do that today. So we're going to break it down. Today we're mainly going to focus on part one. So if everyone can pull the copy of that out, and we'll just sort of have a look at it and read along with it together. So that's our roller coaster assignment.
No, I can't.
Okay, thank you.
Yours not in your binder.
Thank you. Okay. So this is what we're doing. We've got two parts to it. The first part there is just a bit of an introduction about a roller coaster. It just says what they are. Then it says your task is to design a roller coaster using a variety of functions with appropriate translations. We've got a horizontal length of 400 metres and made up of a variety of different functions. So we don't just want it to be repeating quadratics. And we're going to use technology to assist us. So in part one, I've given you some information, and you need to find the equations that match it. So if we look at part A, find the equation of a line, and it gives you the information there to find the line. That's going to be the initial incline for our roller coaster. Part B, find the equation of a quadratic. Okay, so it has a vertex, and then we've got a point that it's travelling through. Then we have a cubic. Part D, find the equation of a quartic. Find the equation of a circle in part E. So we've got lots of different functions, and we're going to combine all that knowledge together to find these equations, and then we're going to graph it. Okay, so I expect you to be able to do part A to G, really. Okay, that's the stuff I've all done before. You may need to look at your notes to remember how to do it, but parts A through G we should be able to do ourselves. Then what we're going to do, I'm going to go through this software up here. Okay, so in Spec I showed you guys GeoGebra. What I want to show you guys today is Desmos, okay, which is another online graphing program. And I think this one's better for graphing. Desmos is better for graphing. GeoGebra can be better for geometry and drawing shapes. So so if you just go to desmos.com on your laptop, don't do it now, I just want to talk you through this. And I'll just show you how we're going to use it. Okay, so the first thing is we're building a roller coaster, right? And this one, one we're building now has a height of about 60 metres. And come on, guys. You're fine.
Nice, Cody. I want to zoom out. There you go.
Height of about 50 metres, 60 metres, and a horizontal distance of about 100 metres. So the first thing we're talking about is our V window. We've got to restrict our V window. Okay? So the way we're going to do that, like here you can see you've got a Cartesian plane. I'm going to put the spanner at the top. Okay? And for X, we'll go from -5 to 100. And for Y, we'll go from -5 to 60. Okay, now, if you do part A, all right, what you'll find is the equation of the line is y equals 2x. Okay, so we've got the equation of a line there. And then the next part is the equation of a quadratic. It is x take, let me just have a quick look here, x take 28 squared plus 51, and it's inverted.
Write it down.
Plus 51 and the a is a negative. Okay, so I just want to show you guys this part, and then the a is 0.2, is it 2? Minus 2 times x take 28 plus 51, and then going through 26. Y equals 2x. There we go. Okay. So it's anyway. This isn't the exact equation. Okay, I can't remember what it is exactly, but it's something like that. What I want to point out is these graphs are both going on forever. Okay, and what you need to do is you need to restrict the domain so that when you have all of these functions, it does look like a two-dimensional roller coaster track. So the way we're going to do that, let's look at this point of intersection here. Okay, 2346. So what that means is we're going to graph this line, okay, until we get to x is 23. So we need to restrict its domain. And so the way we're going to do that, we use these curly brackets, and we're just going to say 0 is less than x is less than 23. And I've minimized the line, so it's just over the period over which we need it. That's where the roller coaster starts at the bottom, gets some gravitational potential energy, and then it's going to unfold throughout the rest of its journey. The quadratic here, then, is going to exist for values. So again, let's open our brackets. 23, okay, is going to be the lower boundary. That's where it starts, okay? So the line goes all the way up to 23, and then the quadratic starts at 23. And then the quadratic is going to segue into something else. We need to find what's the next one that it transitions into, and we're going to need to restrict that domain appropriately as well. Okay, so your in part A, B, C, D, E, F, G, you're finding these equations. 2x and this one here will be quadratic. You're going to find them. Once you've found them all, then you're ready to open up Desmos and start sketching it on the Cartesian plane and trying to restrict the domains appropriately. Okay. Once you've done that, what you're going to do is you're going to provide a screenshot of it. Now you might find you've got halfway through it and you know the lesson's finished, we need to move somewhere else. Okay, what you can do here is you can make an account and you can save your work. Okay, and I do recommend doing that right from the start. Okay, because what I'm going to say about part 2, so I think I've talked enough about part 1 now. It's a roller coaster. Everyone's is going to be the same. Okay, but when we get to part 2, everyone's is going to be different because you're going to create your own. All right. So in part 2, we're going to start with a blank Cartesian plane, and then you're going to need to come up with the equations that describe some roller coaster track that you're going to invent. Okay? And so you can draw a shape like that, but we're going to break it up. Okay, there's a line, then it's part of a circle, then it's part of a quadratic, then it's part of another quadratic, so things connecting into one another. When we do get to part 2 in a couple of lessons time, I will break that down a bit, and I will go through that a bit more. But for now, what I would expect us to get done by towards the end of the lesson, okay, is probably finishing off part 1, getting it on Desmos, getting it there, getting it at least saved, and even making a start on the write-up. Okay, I think that's a pretty good goal. Any questions? Okay, so make sure, finish writing down all the answers on your book for parts A, B, C, D, F, G, and then you can get your laptops out and start sketching it.
Okay, go mark it.
Yes. Did you break my phone?
Yes, look at it, it's smashed.
Oh, it's smashed.